And what's the first one? Dr. Hay is not sure the substances are human, but has narrowed it down to two possibilities. Both of these substances have similar properties. Use the atomic scale marks to provide background to determine the identity of the substance. Be sure to reflect your value and then discuss the question below.
Thank you so much. Before we even jump into the diagram, Dr. Young sent me another email. This is the email that Dr. Young sent. Can I get somebody to read the first paragraph? Julia, go ahead.
Based on your suggestions, I decided to run some more tests on the water sample I took from Westfield. As it turns out, you were right. The reaction between the iron pipes and the fertilizer seems to have produced another substance besides rust. I hadn't noticed it before because it dissolved in the water, but once I removed the substance from the solution, I was able to observe some of its properties.
Kaden Lair, second paragraph.
The unknown substance is a solid, yellow powder at room temperature. It has no odor. Based on these observations, I was able to narrow down this list of possible substances to those that share all of these properties. I think the substance is either sodium nitrite or potassium chromate.
Perfect. I'd like you to determine which of these substances is the unknown substance in Westfield's water. I'm sending along an atomic scale model of each substance for you to use as evidence. Once you've identified the substance, be sure to inform the people of Westfield. So William just read to us that we got sodium nitrate and the potassium chromate. So this is the atomic model that is on your paper. Now we got two different ones. Sodium nitrate. Here's sodium nitrate. Can I get somebody to read to me the properties? Kaden Crowder, read to me the properties of sodium nitrate. Yellow, solid at room temperature and odorless. Kaden Smith, read to me the properties of potassium chromate.
Yellow, solid at room temperature, odorless.
Perfect. I love how Sadie went ahead and annotated that chart. She circled the properties that she saw that were similar. Alright, when I say go, you have 1 minute and 30 seconds to answer numbers 1 and 2, silent and solo. Go ahead. Make sure you tell me about the similarities and differences of the atomic makeup as well. Give me the similarities and differences of the properties as well as the atomic makeup. You gave me the properties. What's similar in the atomic makeup? Don't forget to tell me the similarities and differences of the atoms, the atomic makeup. I want to see what's the similarities and differences in the atoms. You got about 14 seconds left, and then I want to see all pencils down. All pencils should be down in 7. I should have all eyes in 3. Oh, I love all the hands. All right, Sadie, what is similar about the two substances?
Both substances have oxygen.
Oh, she gave me the atomic makeup. So they both have oxygen atoms. What else is similar, Glenda?
Oh, they have the same property?
They have the same properties. They are both yellow, solid at room temperature, and odorless. Elijah, what's different?
They have different repeating groups of atoms.
They have different repeating groups of atoms. They have different repeating groups of atoms. What is a specific atom that potassium chromate has that sodium nitrate does not, Angelique? No, they both got potassium. They don't?
No.
Oh, sorry. Yeah, you're right. Sorry. Angelique is correct. Potassium. What else? Julia? Chromate. Yeah, chromate. And then what does sodium nitrate have that potassium chromate does not? Armando?
So, this will make it like a pool. It's just like the atoms because it's making like a chemical with like spins because it make like when maybe like a yellow and solid and luminous and
Yep, they got the same properties and they both have oxygen, but what does sodium nitrate have that potassium chromate does not, London? Sodium. And one more, Daenerys. Nitrogen. Now I have pictures of what these actually look like, so we can see the properties, but this is what sodium nitrate actually looks like. That's the atomic makeup, and then this is what potassium chromate looks like. So they have the same properties, but what can you tell about the difference in each of the properties? William.
The potassium chromate has the water, the more defined color.
Yeah, potassium chromate has a more defined yellow color. Alright, if you look at the bottom, we got the atomic scale model of the chemical reaction in Westfield's water. Go ahead and answer number 3 and 4 at the bottom. I'm gonna give you about 1 minute. You are just telling me which one do you think is the extra substance in the water. You got 1 minute in the clock, and then explain why you chose that. Based on your atomic makeup. Sorry, Isaac. Which one do you think is correct? Do you think it's the sodium nitrate? Do you think it's the potassium chromate? Or do you think it's both? Make sure you are able to explain. Mr. Moore gave me some sticks for cold calling. So don't be mad when I pick your name. It's Mr. Moore's fault. I already got them ready for you. So be ready to explain. Journey, pick a stick. Jada Buchanan. Jada, based on these atomic scale models, what other substances could be in the water? Which substance is in the water? Sodium nitrate. Y'all agree or disagree? I should see all hands. Show me if you agree or disagree. Everybody agree. Shout out to Jada. So those of you that agree, explain why you agree. Kayden Crowley.
I agree because it has the same atoms that made up the reaction.
Love that. Because we have the exact same atoms that made up the reactants. Remind me, what are the reactants? Isaac, what's the definition of reactants? The starting substances or the beginning substances. And what is a product, Angelique? The ending substance. So what are 2 products?
Yes.
Rust and sodium nitrate. Rust and sodium nitrate. Alright, go to the next page. So yesterday when I looked at our exercise, we had a bit of trouble with the law of conservation of matter. So before we even finish this lesson, I want to touch on the law of conservation of matter. What is the law of conservation of matter? Caleb.
Matter cannot be created or destroyed.
Matter cannot be created or destroyed. So if it is in my reactants and I have a chemical reaction, where is it going to be in my products or not? Yes. Do they all have to be in my atoms in my reactants have to match my atoms in my products?
Yes.
Yes. Can I have more than one reactant?
Yes.
Can I have more than one product?
Yes.
What should you do? What's the first thing you should do when you have this problem? Count. Please count the atoms. Make sure you annotate the atoms. I'm going to give you 4 minutes to read and annotate and answer these 2 questions. We are preparing for our 10 ready. On our 10 ready, you only have about a minute and a half per question. I'm going to be nice and give you 2 minutes today on each question. I love how Journey wrote her name at the top because I am taking this part up. While you are working on this, I'm going to pass out your chapter focus tag. Coming around to look for the best annotations. Choose the best annotations. Give a incentive as well. And I'm going to share your work on the doc cam because if you annotated correctly, I know you got those answers right. You got about 2.5 minutes left. Got about a minute and a half left. Make sure you have annotated. Oh, look good. Look at that. I'm not telling you. Make sure you do the one on the back as well. There's 2. them together. Peroxide, you got one.
First breaks apart to form water and oxygen, and the valuable form hydrogen atoms are white and oxygen atoms are green.
Okay. Alright, what does the arrow in between each of these answer choices mean? Angelique? It means we had a chemical reaction, and during a chemical reaction, my atoms do what?
Rearrange.
Rearrange. Alright, so we got 4 answer choices. Which one would you eliminate first? Which one would you eliminate first?
D.
Ooh, hold on, don't call it out. Which one would you eliminate first, Kennedy?
D.
Why?
Because the pilot, it has no, water.
Okay, she said she would eliminate B first because we don't got no water molecules. And if it's in my, because of the law of conservation of matter, if it's in my reactants, it has to be where?
Product.
My products. I'm gonna put trash. What is the next one that you would eliminate, Kate and Laird? D. Why?
There's too many atoms.
We got way too many atoms. So if you count the atoms, how many atoms should I have?
4, 8.
8. We got 1, 2, 3, 4, 5, 6, 7, 8. And then here we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got too many atoms. So that's trash. What was the next one that you would eliminate, Glendon?
A.
A. Why?
Because it's gonna bring all the products. I mean the atoms.
Because I don't have all of the atoms. What am I missing? What you say, Elijah?
I said the answer is C.
I mean, well, somebody said what I was missing. Somebody said what I was missing. What am I missing?
Two element molecules.